Hi guys, welcome to the Matplotlib Essentials lecture. Matplotlib is the most popular plotting library for Python. They say on their website, Matplotlib tries to make easy things easy and hard things possible. Matplotlib was originally written by John Hunter to visualize electrocardiography data for epilepsy patients during his postdoctoral research in neurobiology. He created this library to replicate MATLAB's plotting capabilities in Python. If you have ever worked with MATLAB, Matplotlib will feel natural to you. Later on, this open source library emerged as the most widely used plotting library for Python programming language, and a core component for scientific Python stack, along with NumPy, SciPy, and IPython. Along with providing great control on every element in a figure, Matplotlib is very easy to get started for simple plots. Matplotlib is very customizable in journal as well. And with just a few lines of code, it generates high quality plots, histograms, power spectra, bar charts, error charts, scatter plots, and much more. The official documentation of Matplotlib is provided on its website. This is a great idea to explore Matplotlib examples and tutorials on its official website. You can follow this link on examples and you will see a gallery matplot API, and you will see configuring the font family, Unicode minus, text watermark, and so many other examples. And if you follow the tutorial link, you will find that introductory, sample plots in Matplotlib, customizable Matplotlib, an image tutorial, user guide, and much more. So, moving forward, in this section, we will learn Matplotlib's key features with examples. Let's get started. Before we move on, I hope you have already installed this state-of-the-art library. If not, follow these commands: conda install matplotlib or pip install matplotlib to install this library. Let's start with the new Jupyter notebook, file, new notebook, Python 3, and here we have a new Jupyter notebook. So I have already installed Matplotlib. So the first thing first, we need to import Matplotlib. So we will say import matplotlib dot pyplot as plt. So we are importing pyplot from Matplotlib as plt. So this is the regular official way of importing this library as plt. So let's run this cell. We are working in a Jupyter notebook. Jupyter Notebook provides a convenient way of printing the plots within the notebook using matplotlib inline command. This is only for Jupyter notebooks. If you are using another editor, you will use plt.show at the end of your plotting command. This will pop up the figure in another window. So because we are working in a Jupyter notebook, we will write matplotlib inline. Let's run this cell. So now we have executed this command, so we will be able to get the plots within the notebook. So moving forward, we need to work with data. Let's start with a simple example using two NumPy arrays to plot numbers along x and their squares along y-axis. So to do this, we have to import NumPy as well. Import NumPy as np, and now we want x equal to np dot. We can use a range here, and we want 10 numbers, so let's pass in 11 here, and our y is the square of x, so x square, so this is lowercase, and let's run this cell. As we know, it's always good to see the data, so let's print x. We have 0 1 2 up till 10, and let's print y. So we have 0 1 4 9 2 square 3 square and so on. Let's add some cells here. So let's start with the basic plotting. So we want a line plot. We have data x and y, so we can simply call plt dot plot, and if you want, shift tab and you can see the document string for this function, plot xy. So we need to pass in x and y. So let's pass in x, y, and see how the result look like. So here we have the basic plot, which is a line plot, x along x-axis, y along y-axis. We want to set its labels. So what we can do, we can call plt dot x label, and we say x axis, and let's copy this one, and we also want y label, so we only need plt dot y label, and here we have y axis. Let's run this and see how the things changes. So here we have x axis, y axis. So let's give the title to this plot, so we can simply say plt dot title and pass in the string figure x and x square. Let's run this cell. So here we have title, we have y-axis, we have x-axis. So remember, we said we are using Matplotlib inline, so we don't need to type in the plt.show command. If you're not using a Jupyter notebook, you need to call plt.show and run this. It will print out the plot using this show command. You notice that even in this Jupyter notebook, using plt.show, you are printing this plot, and if you comment this plt.show, you will see you are getting output because you are getting this red cell as well. So moving forward, how to create multiple plots on the same canvas. So we have this canvas and we want to put multiple plots on this canvas. Subplot is a function in Matplotlib which provides a convenient way of creating multiple plots on the same canvas. So let's call subplot here. Plt, we can call dot sub, and you can press tab, and this is subplot. So which arguments we need in this one? We need n rows, how many rows we want, how many columns we want, and then the plot number. So let's pass in 1 3 1. So we want 1 number of rows, 3 number of columns, and 1 as a plot number. Let's put some data on this canvas as well. So plt dot plot, we want to put X and Y, and we can say we want red in color. So let's run this cell here. So here we have a plot with color red on our selected canvas. Let's copy this one, and we said we want 1 row 3 columns. So what we are going to print on 2. This was the plot 1, so now we want to select the number 2 in the second column. Let's plot Y versus X here and say we want green, and let's run this code again. So here we have green and here we have red. Let's copy this again, and we have, as we know, we said 3 columns, so we have the third canvas empty, so we can say we can call third one here. Now we can plot both X and Y and X on the same canvas. So let's pass in X here, Y here, and say we want green with star, and say red with star, and let's run this one here. So here we have the first plot XY in red line, second plot at plot number 2 with green line, and the third plot at plot number 3, green stars as X and Y and red stars as Y versus X. We can say we want line along with these stars, so we can pass in this for line, and say we want this dotted line. So for dotted line, so twice of these symbols. So for dotted lines, twice of these symbols. So let's run this cell. So now we have the red dotted line because of this symbol. So we have the green dotted line, and in this third plot we have the star and line. We have the star and line. If we want, we can pass in. Now here we have star and dotted line. So one thing you notice that these axes are kind of overlapping. This is very easy to fix. What we need to do, we need to call plt.tight layout, and with this simple one line we are going to fix this issue. And here we have, they have some space, they are kind of not overlapping anymore. So it looks like the lecture is getting longer now. Let's split it here and see you in the next part of the same lecture. Good luck.